Question is, two boys simultaneously aim their gun at a bird sitting on a tower. The first boy releases his shot with a speed of 100 meter per second at an angle of projection of 30 degree with the horizontal. Second boy is ahead of the first by a distance of 50 meter and releases his shot with a speed of 80 meter per second. So in this case we are going to find out three things. First is, how must he aim his gun so that both the shots hit the bird simultaneously? B part, what's the distance of the foot of the tower from the two boys? And C part, with what velocities and when do the two shots hit the bird? So in this case we are going to find out. First of all, let's draw the description of the question. This is x-axis and this is y-axis, and with the tower, let us suppose h is the height of the tower. This is boy 1 and it fires a shot and the bird is sitting here, and initial velocity, let us call it u1 at an angle of 30 degree. There is a boy 2 which is 50 meter ahead of boy 1 and it fires a shot, let us suppose with the velocity of u2, and we have to find out this angle also, let us call it theta. This is the foot of the tower, let us call this distance x2, and total distance will be, let us call it x1. First of all, we can say that x1 is equal to 50 plus x2. So let's find out what are the various things which can be found out by the basic information that is given in the question. So we are going to start from the boy 1. For boy 1, the horizontal displacement x1, vertical displacement is h. Now we have the horizontal component as well as vertical component of u1. We can write u1x is equal to u1 cos of 30 degree, and its vertical component u1y is equal to u1 sin 30. For boy 2, we can write similarly horizontal displacement is x2, vertical displacement is h. The horizontal component, that is u2x, will be equal to u2 cos of theta, and its vertical component u2y is equal to u2 sin of theta. In both the cases, the acceleration due to gravity or acceleration of first and second will be same, that is minus of g, and let us assume that t is the time. Let us say t is the time when both shot, two shots hit the bird. So let's write the equations for the boy first or boy 1. We can say that vertical distance y, s of 1y, will be equal to u1 by t plus 1/2 a1 by t square. So s1y is h, u1y is u1 sin 30 minus 1/2 g t square. Now we already know the value of u1, so we can write that u1, replacing u1 is given as 100. This will be 100 sin 30 multiplied by t half gt square. And similarly for boy 2, we can write it as s2y is equal to u2y t plus half a2y t square. In this case also it will be h is equal to 80 sin theta multiplied by t minus half g t square. So we can equate these two equations. Let us call this equation number 1 and equation number 2. You can say that equating 1 and 2, we get 100 sin 30 multiplied by t minus half gt square is equal to 80 sin theta minus half gt square. Gt square cancel by gt, t cancel with t, so we can write this as sin theta is equal to 100 divided by 80 sin of 30. This solution will be coming as 50 by 80, or we can say the theta will be equal to 3860. Next, similarly, we are going to find, now use the horizontal component, like we say for boy b1 or boy 1, we can say that x1 is equal to u1x cos 30 multiplied by t, and for boy 2, we can say that x2 is equal to u2x cos of theta multiplied by t. We already know the relationship between x1 and x2. So x1 is equal to 50 plus x2. Substituting the values, we get this as u1x cos 30 multiplied by t equal to 50 plus u2x cos theta multiplied by t. Taking t as common from this term as well as this term and substituting the values, we get 100 cos of 30 minus 80 cos of 60 is equal to 50. From here we can find out t, that is equal to 50 divided by 24.152, so So t will be coming as 2.070 seconds. Now we can find out x1. So x1 will be equal to 100 cos of 30 multiplied by time. Time is given by 2.07. This will be coming as 179.27 meters. And x2, similarly we can find out that is 80 cos of 30, sorry it should be 38 I think, let me check. Yes, 38 cos of 38, 60. This will be coming as 129.27 meters. And height h, we already know the formula. You can write 100 sine 30 multiplied by t minus half into 9.8 multiplied by t square. Substituting the value time t, we get 100 sine 30, and time is 2.070 minus half into 9.8 into 2.070 whole square. So we can say that height will be equal to, this will be 103.5 minus 20.996. So h will be equal to 82.504 meters. In this case, we were supposed to find out for the second case, we were supposed to find out theta. We already found it. What is the distance? We already found out this one. And with what velocities and when do they two shots hit the bird? So we already find out that this time, and we already need to find out what will the velocities. So in order to find out the velocity, we can use the simple formula for y1. We can say that v1y is equal to u1y plus a1 by t, and for y2 we can say that v2y is equal to u2y plus a2y into t. So let us first of all solve for v1y. So v1y is equal to u1y was u1 sine 30 minus g into time t. So substituting the value of u1 was 100, so this is 100 sine 30 minus 9.8 into time t. Time was 2.070, so this is v1y. And similarly we can find out v2y. So v2y will be equal to u2 sine of 38 60 minus g t. So this is given as 80 sine of 38 60 minus 9.8 multiplied by 2.070, so this will be u2y. And in both the cases the horizontal component will be same, so it means v2x will be equal to, v1x is equal to u1x, and we are going to have v2x is equal to u2x. as the horizontal component remains same. So if the velocity of y1 is given as v1, so this will be equal to v1x square plus v1y square, its square root. Similarly, you can see that v2 will be equal to v2x square plus v2y square and its square root. This way we can find out the third part also, that is with what velocity they are going to hit the birds. Thank you.